Then, for talk for tonight, we are very happy to announce that we have actually somebody from the community stepping forward and sharing the story with us here. Klaus has worked at TGW for, I think, over 13 years at this point, almost 7 years as their software architect, and in that time he led and support a huge migration effort, modernizing the big monolithic application all the way from .NET Framework 2.0, and I checked that yesterday on Wikipedia, that's 21 years ago, all the way to .NET 10. How did they do it, and did they survive it? Let's find out. Please, big round of applause to our speaker from tonight.
Mikro good. Hi, welcome to Modernizing Monolith. I'm Klaus, I'm software architect at TGW, and initially I started off in the .NET area, was working deep in the base libraries on the .NET framework, and in the last recent years I was heading more into the build and delivery mechanisms. Part of this will be the Git migration and Azure DevOps migration that we're gonna touch today, and eventually at some point in time this bigger containerization strategy and initiative that resulted in pretty much the core of the topic, the .NET Core migration. Up front, the disclaimer, please don't see this as a best practice, maybe see it as some learnings, as some failings on what did work, what didn't work. If there are any questions along the way, please just raise your hand, shout out, whichever way. As long as they are small, I'm going to try to answer as quick as possible. And worst case, we're going to run it at the QA in the end. And especially afterwards, I'm more than happy about any recommendation or ideas on what could be done better or what could have been done better. This rough outlook for the day. I'm going to give a bit of context what we're doing in. A little bit scared because early on there was the joke that the 25 slides were going to come for the company introduction. It won't be 25 slides, but it's going to be a few minutes because we have a kind of a special environment, say it this way. We have special requirements, but you will see this one. Then I'm going to give you a little bit of a .NET timeline. From the actual migration, we're going to start more off in the 2015-ish area. Initially, I wanted to spend more time on what happened until then and what was done, which way and why. But there are timing issues, and afterwards it was, okay, crap, I'm already far beyond an hour, so I'm going to have to scrape this or at least cut it short. Some preparation steps leading up to the migration, then the actual .NET Core, and then a quick wrap-up. So, what are we doing at TGW? We are building warehouses, huge automatic warehouses with millions of crates and hundreds of devices. And the big challenge, we have this hundreds of times. Those are pretty much the public available customers that are the reference customers. Yeah. And in those warehouses, we have hundreds of devices that need to be tightly orchestrated and tightly controlled. And those devices can be trains that go around on the rails and grab the individual bags from the racks. It can be automated shuttle systems. It can be conveyor belts. It can be AMRs and AGVs or palletizers, because we have some kind of customers that are more in a grocery and that want to have the warehouse not for sending you the individual packets at home, but they want to stock, for example, their store outlets. And then it can be, those are the 200 packages that need to be delivered to this store. It needs to be automatically palletized. So you need to find the right stacking order, how you can pack it the densest way, and so on. It can be pick stations that need to be tightly controlled. And in the end, every customer is kind of unique. The customers come to us, they have the rough outlines on the order structure, on the sizes of the packages they want to be delivered, and we deliver everything from the ground up. Each site is pretty much scaled and designed for the specific customer requirements. And yeah, standardization is a big factor. It is important for us so we can deliver the sites quick. So we have to reuse as much as possible. But in the end, each site is unique. Many of the processes, the order structures, the strategies that need to be implemented for each specific customers, they are tailored to the customer's needs. This means each and every site has different application codes and different database codes running there. On the upside, we usually don't have those dynamic scaling requirements because we pretty much know upfront when the customer orders. Those are the processes, those are pretty much the transports and the package that needs to be delivered within an hour. An hour is usually our reference mark. So we can say, okay, this site needs 64 CPUs and 500 gigabytes of RAM, and we can scale it for this. So this one is at least rather static, at least for the peak times. There can be lower times, but yeah. Many of the components are time critical because we are controlling the PLC, the devices rather tightly. The rule of thumb is some kind in the order of 10 to 20 milliseconds of round trip time for any important decisions. The load carrier is going on the conveyor. You know, at this point in time, there's a decision that needs to be done, go left, right, or straight. So you need to be pretty much on-prem within the customer's warehouse, within the customer's infrastructure. And from development point of view, there's a split within TGW. We have the central product development. And the central product development is focused on Austria and Germany. They create the base products. It's around 100 developers in around 10 teams on 10 different components, 10 different products, estimates. And on the other hand, we have the realization teams. The realization teams are sitting worldwide. They take the products that the product development team creates, and they customize this to the customer's needs. Realization departments are sitting in Austria, Germany, China, Spain, France, Italy, UK, and US. And as a rule of thumb, there are 300 to 400 developers working on the products worldwide. That's the rough intro of where we are running our software in, so you have a rough idea. Yeah. The road to hell is paved with good intentions. And you can see the icons up here, a silver light shining through, a WCF and so on shining through. And yeah. If we have a greenfield project and we can start from scratch, we have .NET 10, we have GitHub Copilot, we have the Azure DevOps pipelines, and everything's fine and super easy and great. Now we have to go somewhere over here. 2005 was a great year for source control. Pretty much Git was released and TFS came out along with the Team Foundation version control. It was also the year that .NET 2 came out. Our .NET journey didn't start in 2005, but we already shipped code and projects to customer sites in there. So back then we were using Subversion, SVN, and for lack of better alternatives, we had some kind of a homebrew build infrastructure. So we at least had everything in source control, and it was pretty much built from source control, and you had the revision references. But yeah. In 2006, WPF came out. WPF is still in use. WCF, the Windows Communication Foundation, and pretty much one of the worst parts that I've ever worked with, the Windows Workflow Foundation. It was a promise and it sounded great. It had 0 testing capabilities, so it was god-awful to work with. And what it did to source control on the deltas and diffs was insane. 2008, Silverlight and Unity DI came out. And Unity DI is something that we're going to take a look at, unfortunately, a little bit deeper later on. But this year is also when the product that we will take a look at later on was launched and started off. Initially started off as a successor to an old C Linux application. It was started brand new from scratch in the best that Microsoft had to offer, which was on Team Foundation version control with WCF, with the Windows Workflow Foundation, .NET, Visual Studio, and everything. Sorry, I missed one part. This small pillar down here. In 2005, the company I worked with had a revenue of 200 million euros per year. This is something that's going to become important later on. In 2010, already over 15 years out, Asia was brought out. So this is already 15 years ago, but our product started earlier than Asia. So this is something that we can tell. Back then it was called Windows Asia. At least in theory, Nougat was delivered. It did work kind of, it didn't scale, it didn't work well. So yeah, it was there, but it wasn't actually usable, at least if you had many projects that need to be restored. And luckily, the managed extensibility framework came in. We did have the customer requirements that we have customization in there, so the managed extensibility framework for add-in loading mechanism, which was the Microsoft proposed way. Yeah. In 2010 already, we had an order intake of around 300 million euros. I had to switch from revenue to order intake in there because for 2005, I didn't find public order intake numbers, so I had to fall back on the public revenue numbers. But around 2010, we had an order intake for 300 million per year. Around 2010, 2012, 2013, pretty much the rise of GitHub was. GitHub became popular, became huge, and became large. And in around 2010 to 2013 time slot as well, the task parallel library came at first, and building on some of the APIs that were coming in there was async and await. And the world from .NET point of view was nice again. In 2013, this was when I started the company. I wouldn't say that I'm the reason that everything went better, but just to give you a word of perspective. So that was 2013. And in 2015, Kubernetes version 1 came out. Kubernetes version 1 was pretty much the starting point for the CNCF, the Cloud Native Compute Foundation, which is a long time ago as well, but it started 7 years after our product was developed. To give you just some kind of boundary on why the hell did they do that in the first place? Yeah, because nothing else existed at some point in time. So it had to be done in a crappy way. And around 2015, we didn't have GitHub or something like this. We had the MSDN magazine. And the MSDN magazine, there was the architecture for hosting third-party .NET plugins. This was on the title, as well as introducing Visual Studio Online, which was the new stuff at the time. We were talking about collections and organizations earlier. This is where it originated. And the how-tos on creating your first Nougat gallery. And of course, back then, the most popular thing ever, the enterprise library. The enterprise library was pretty much the go-to where Microsoft bundled their patterns and practices with, if you build an application, that is the way to go. And around 2015, we were running on a full Microsoft stack. I wouldn't say that we were picture perfect to the enterprise library and their patterns and practices, but we definitely had all of the stuff in there. I wouldn't say that everything was quite as intended, but at least it was in there. The builds were running on some kind of a homegrown build infrastructure, which was pretty much self-managed virtual machines. And we had two main products, two main .NET products that were sharing the same libraries. Everything was great. PD created the products, checked it in, compiled them. Output of the build infrastructure was a shiny MSI that we were giving out to the realization teams. Realization teams installed the MSI on the Windows machines that were running in custom environments. But yeah, where do the customizations come in? Realization teams luckily had good driver knowledge, so from one guy to another, the base templates were passed on, some kind of a shiny artifact that had to be given, because we as PD, we didn't have anything better in place yet. So it was pretty much the driver knowledge that was passed around. Everybody had their solutions for the different customer projects. They were checked in to source control again. And yeah, they compiled it as well. The output or the outcome of their compilation of their build infrastructure were pretty much some libraries that you had to place in magic places on the file system. And when our server started up, it was, and here's the customization with the managed extensibility framework that we have to load and that we can load. The overly dramatic reasoning, and it wasn't phrased this way, I have to be fair on this one, it wasn't phrased this way, but the general assumption was we don't want to deal with your application internal layerings. If you're using application A or B or library A or B internally, this is your problem, you reference it, we don't want to know this is your problem. Which is kind of the opposite of an inversion of control pattern. So our core library expanded and expanded and expanded, and we had shitload of reference to here and there and everywhere, because that's what we needed to provide the functionality on top, and on top just wanted to reference our library, and that was it. All of this worked some way, but we had to suffer a lot of the consequences based on it. If you guys are writing code and you are just placing add-ins in there, this means we have to be binary compatible. Introducing an optional parameter, at least in theory. Updating an assembly reference, because from .NET point of view, there's a difference if you reference 13.0.1 or 13.0.2. So the assembly loading had to be done. We had to do automatic assembly redirecting and assembly injection in there. Okay, this library, this assembly wants to load 13.0.1. We were checking, okay, we already have 13.0.2 loaded past this one, back, and we had shitload of stuff in there. Usually stuff that the compiler would take over and the compiler would solve. Not sure if anybody's ever done app domain handling and passing around data between app domains, marshaled by ref, and running into shitload of performance issues along the way. Everything along the way. And I'm sorry, I have to cut this short. Initially, I wanted to have this one. I wanted to go a little bit into a little bit more detail on those topics, but yeah. Realization still had to struggle with passing around their template code. Long before the actual .NET Core migration started, there were some preparation steps. It wasn't necessarily because, yeah, we want to go to .NET Core at some point in time. This wasn't even up for debate yet. We just knew the way that we're currently doing doesn't work any longer. We need to make changes on this one. We had the numbers for 2010. In 2010, we had around 300 million of order intake. In 2015, we had around 450 million euro of order intake. So pretty much in those 5 years, we had another 50% increase. And finally, in 2015, Microsoft brought a lot of stuff. Pretty much .NET Core 1.0 came out. They finally brought an IOC container. NuGet started working. It wasn't just in theory, but no. And this isn't to this NuGet. But if you think of the first NuGet versions, where you had the packages config, where you had the reference in each file, it was insane to work with. And it wasn't easy if you had 1 project or 5 projects but we were talking about 3-digit number of projects. And the NuGet restore, when 100, 200, 300 projects had to be restored, this was, yeah, I'm not going for a coffee break. Now I'm going for lunch, and hopefully when I'm back from lunch, it's finished. But at some point in time, NuGet worked out the internal stuff. They changed from the packages config to the packages reference. It became reasonable from a source code point of view as well, and from a performance point of view. 2018, Microsoft bought GitHub, and Microsoft announced Azure DevOps as well. And Azure DevOps, pretty much the Visual Studio Online rebranded version. They had the build infrastructure, they provided build infrastructure in there as well. And a little bit later, Microsoft finally brought a JSON library. So you could convert your objects into JSON, you get serialized, deserialized, back and forth. And it worked fine. But if you think of it, that's 8 years ago. And finally, .NET Core 1 was coming in around 2015 after years of boiling the ocean and over-promising and under-delivering. .NET Core finally came to this unifying approach with .NET Core 5. That's the future for the full framework as well as for .NET Core. That's pretty much where we focus on. There was a clear statement from Microsoft on how this is going to continue, and at least for everyone it should have been clear, .NET 4.8. It's not dead, it's going to getting security updates, but there won't be any investments in there, there won't be major stuff in there. And that's pretty much the timeline that we're going to focus on right now. We were on this stack, and we were not on Git, not on Azure DevOps, we were on the full framework, and it was, okay, what are we going to do? So in this timeline between 2015 and around 2020, we made those migrations, something that we're going to take a look at in more detail. For reference for you, in 2015, the order intake was 450 million. In 2020, we were on €1 billion per year order intake. So in those 5 years, we doubled. And doubling is always nice from, yeah, we're the best guys, we are getting shitload of money. Yeah, we're also getting shitload of work that needs to be done. Because although and let's give boilerplate numbers, you double the order intake, you double the work that needs to be done, but does this mean that you need to have double the resources? And what about the training effort? And we are on a completely proprietary stack where the rule of thumb was, if somebody starts right now, a year from now, they're going to be usable. Up until a year, it's going to be side quest here, side quest there, getting introductions, working on small areas. But around after a year, you could give them, hey, that's a new Jira item, that's a new story. How could this be solved? And they could start working along. One of the first steps that we did was migrating from the Team Foundation version control to Git. There's on GitHub, there's this Git TFS, where you can pretty much bring out commit by commit by commit Team Foundation version history into a Git history. Azure DevOps does provide some capabilities of import from Team Foundation version control, which is take it from there and take everything as is, bring it with one commit, or think around the last half year, something in this order of magnitude. But no Microsoft or no Azure DevOps tools said, okay, give me your Team Foundation version control, I'm going to import everything. And it is with good reason. Because the Team Foundation version control branching structure is so different, and I wouldn't call it, I'm not calling it crappy, but it is, if you are working with Git, a branch is pretty much a lightweight object, which is pretty much a pointer to one specific commit. In Team Foundation version control, a branch is a structured item. You can see this was committed on this branch, it merged down here. You see all those information. And maybe a little bit, maybe really a tiny maybe, the branching structure was massively misused on our side. So we had repos, the repos had folders, within the folders we had branches. And this is something that could be done with Team Foundation version control. So it took us a long time to figure out, so this Git TFS tool, how do we actually need to call it, and which baseline parameters and which starting branches do we need to pass in for all the history to come out, which is very nice because it's being done commit by commit by commit. So on Friday, before leaving for the weekend, you start the migration. And on Sunday evening, it's, oh no, I can't continue exporting anymore because this branching structure is not in your allowed list. And you need to find a different base branch where it derived from. So it took a couple of weekends until we had the complete information repo by repo out. And finally, we had the Git repos, at first the individual Git repos. But with Git, you can do the Git allow unrelated history and pull everything in. So we had one big repo with the different products on dedicated branches, and ultimately the different branches were brought together. So we migrated to a monorepo. In this monorepo, we still to this day have the complete source structure. So this connection manager class that's seen in here, we can still see the commits from 2012. I'm sorry, there's a commit from 2011. But that's pretty much the end that I've seen, at least in this screenshot. This code is still actively in use. It's on hundreds of sites. But we still have the complete history and can see what happened, why, where, and who to ask. Unfortunately for me, in this commit history, I turn up a lot, so yeah. Full disclosure on this one, 7 years after going to this monorepo, part of those core libraries were being moved out again. In hindsight, I would definitely introduce the monorepo again because you actually could do refactoring. Earlier we had 10 different repositories, which is quite nice because I'm developing a feature here on how I think a library should be used. Then I'm going to release my library, hand it over to, hey, take a look at this library, and it's, yeah, that's crap. The APIs don't work for me. The same with refactorings and so on. And if you have everything in one repo, you can do all in one go. You can make the refactorings, you can make the changes, you can take a look, does this actually work? Are the APIs fitting the target components? And once everything worked, then you made up the pull request and then you committed it in one go, and you didn't have shitload of commits in between. But everything for its time. Back then, completely agree and completely behind that the monorepo was introduced. And I also do agree that it was time, at least for this area, that the monorepo was disbanded and the component was moved out again. Because back then, we had one component that was shipped. Now, we have 10 that should use it. We migrated the messaging. Because we're an enterprise company, we need to have an enterprise service bus, which, being enterprise the way it is, Microsoft is the way to go, and we have MSMQ in there. And this enterprise service bus, it provided tons of features that we didn't use and that we didn't need. But the features were in there. However, it forced us to bring a lot of workarounds in there. Being Microsoft messaging use, it pretty much relied for clients to access the MSMQ on the server. I don't want to call this a security nightmare, but I think it's at least close to it. So we brought web applications in between that took the HTTP messages or REST messages, translated it over MSMQ and so on. And here as well, there may have been some kind of self-inflicted design decisions in there that made it worse. So you can have the best of ambition, say, yeah, I'm going to want to hide all of the complexity for the application teams so they don't need to deal with all the internal event handling, event subscription, and so on. This is completely fine. That's what libraries are for. Bringing a base class that all the applications then have to derive from, for all the facades, which in the end led to this complete messaging system and the binary compatibility to it, because the base class was provided, but the third-party data structure was part of the public code definition. So at some point in time, we couldn't make one patch update because it broke compatibility. So we got rid of the enterprise messaging, enterprise service bus. And in the first step, we were migrating to Redis. I'm not sure if anybody has ever worked with Redis messaging or Redis streams for messaging. It's awesome. I love it. Unfortunately, I was one of the few who loved it. Redis streams is pretty much a lightweight Kafka. So you could have your streams that you write your messages into, and then you have a pointer how far you've already read. From debug point of view, it's great. You can see those were the last 100 messages. On this application, it failed, but yeah, 5 messages earlier, that was the message that triggered the failure. Redis streams was fine. Maybe it didn't have the lobbying behind it, so at some point in time, we migrated to RabbitMQ. It was more for the Java guys. The Java guys were more in favor of RabbitMQ. It was not the hill I wanted to die on, so yeah, okay, be it, have RabbitMQ. The important part though is, when we did this migration, we didn't say, okay, we're gonna go to this messaging route. It was more, the messaging has to become transparent to the application teams. Can this be seen in the back? Can you see it, or can you read this rough code? I'm going to show you one sample. It's not a representative sample, it's a is this? No, this is not big enough. There's my mouse. How can I zoom in Rider without the mouse wheel?
You can do shift.
Sorry?
Double shift and then enter zoom.
Ah.
Yeah.
And that's really just a sample. We pretty much wanted to make all the messaging internals from the application teams. And what we brought up is something that we call proxy messaging. In the end, nobody wants to do messaging. They want to provide services. They want to provide functionality, and they want to consume functionality. So what we did was, from an application point of view, you can describe the functionality that you want to provide as an interface. You can, for example, have a method called start sequence operation that takes a specific input parameter, or input parameters. We said, okay, this method can fire an event, which is then the request response via event. So at some point in time, or somewhere within this code, we should have this snippet. Fires event sequenced operation complete, and here we have the And here we have the event handler. And that's pretty much all the application teams had to do. Application teams described the functionality that they wanted to provide. And they didn't have to deal with the underlying messaging at all anymore. This is something that we pretty much took away from them in a good way. So is my presentation now zoomed as well? What's this? Shift, zoom, and awesome. Shift works in PowerPoint. Thanks. And what applications then could do, they just said, I want to have a messaging connection and I want to expose a service. They pretty much instantiated their interface in their regular lifecycle. In that case, this is the MFC adapter, and then just called on this connection, create a service facade of interface type. And what we did underneath, they passed in the reference, and from there on, we had pretty much everything at hand, because via metadata, we could take a look. What are the actual methods on this one? What are the events being created? If this event is declared on the interface, it has to be in the class, so we pretty much automatically subscribed to the events on the base instance, and we could automatically wire to it. On the other hand as well, if you wanted to consume a service that was provided somewhere, you didn't need to deal with the messaging explicitly. You could just say, I want to have a service agent for this specific interface type. And you got an object of T where you could just call your methods on, where you could subscribe on, and we dealt with the underlying messaging, and application teams didn't have to take care of this at all anymore. At some point in time, we changed from Redis to RabbitMQ. There was some kind of abstraction pleading along the way, but I wouldn't call it negligible. It was at least manageable. The first implementation, that's this one in here, was still a little bit clumsy, but the current state is a nice, clean, and sexy interface. We can take a look at this one afterwards. The next step after messaging migration was pretty much migrating to Azure DevOps builds. Until 2020, we were pretty much running on this homebrew build infrastructure. It did work. It did have some great features in there. You could pretty much connect to a database schema and say, I want to have all the stored procedures in there, or reverse engineer procedures, connected to the database schema, ran out all the stored procedures, all the views, persisted it into the local file system, so you could commit it to source control. It created .NET proxy code, so for each stored procedures, you got the individual method call in there. The features it had were great, but we needed to maintain 20 to 30 build machines, which is updating the compilers, updating the dependencies, running the Windows updates. It couldn't scale horizontally, or it couldn't dynamically scale horizontally. The horizontal scaling was pretty much done through configuration, installing a new build server, configuring a new build server in the build infrastructure. If you came in and wanted to queue 5 builds, those were queued to the same build server, so you need to bring in different configurations so you could parallelize it. And we didn't have any pull request integration. The build infrastructure, it wasn't bad, it was fine, it was pretty much a child of its time. And at some point, it became obvious we need to find something else. Azure DevOps, the actual migration from the builds, most of it was rather clean and was rather easy. We didn't have all the features that we had earlier. We had different ones like the pull request validation. And for maintenance effort, the maintenance effort dropped tremendously. And even better, the automation increased even more, because you could just have Azure DevOps pipeline. You could just create a new YAML and say, fire it up on the pool. I don't care. You had a pool of initially 5 pipelines concurrently, then we had 10, then we had 15, then we had 30, now we have 40 in the Microsoft managed instances, and I think 50 in the on-premise network binding. It's still Azure managed, but it has network binding, so we can run integrated tests against internal Oracle databases or OpenShift clusters and so on. So if I just want to burn money, I can go there and say, okay, I want to fire up this pipeline 200 times, and 20 minutes from now, everything is done. At some point in time, everything's scaled up. At some point in time, it's going to scale down again. This combination that we now had Git as a distributed file system, and a distributed is a vastly different system than a centralized version control system. If you have a distributed, you don't have a central authority. You're pretty much working on hashes along the way, and there is no single owner of hashes. And with this automation that we had, the Azure DevOps pipelines, we suddenly knew all of the different realization engineers in all of the different Azure DevOps projects, they have the same infrastructure as us, exactly the same. They can fire up the same stuff. And what's even better, we can now ship code to them in an automatic way, because we can just say, this is our release repository, this is where the boilerplate code is in, this is where the starting point, the starting solution is in. So we had pipelines that pretty much started off on our internal code repositories. The internal code repositories, they were internal and private to the team. The team could do whatever they wanted in there as long as it works for them. But if they wanted to give out the release, they started off, or they are starting off a stage pipeline. And the stage pipeline does whatever magic it has to do for one specific component, compiles everything through, creates the NuGet galleries, or creates the NuGet packages, uploads it into the Azure DevOps feeds. And in this stage repository, we now have a working solution. And this working solution has the exact diffs to the last release, and it's compilable. It has all the Azure DevOps pipelines in there. Inside the stage, well, the stage repository, technically speaking, is still private to the team. They can run some additional QA checks in there, some quality assurance. But at some point in time, it's going to end up in this release repository. And realization teams can now just go there. I want to start a new project. I'm going to clone this repo in, and I have everything to get started. I have an up-to-date solution in there. I have an up-to-date build infrastructure, build pipelines, and I can clone this repo in, commit it to Azure DevOps, fire up the first pipeline, and everything is fine. We can also ship updates to the station, to these component pipelines. And for realization, at some point in time, they can just do their git pull upstream. And oh, the .NET framework changed from .NET 4.8 to 4.8.6.0. And depending on the pipeline that they're running off, they get a different outcome. This actual migration is process-heavy steps. It was a stretch bringing this here to the .NET meetup, because it's not that C#P.NET-y. However, yeah, if I want to go to or if I'm going to a .NET meetup and then some guy starts rambling about Azure DevOps pipelines, YAML and Git, and some of them, yeah, okay, maybe slightly in the wrong direction. However, I wanted to bring it here because it enabled so much for us for the actual Git for the actual net core migration. That we had this functionality in there, that we had this release process, allowed us that we could ship upgrade paths and migration scenario to our customers. That's pretty much the core part of it. That we had at some point, at some part in time 4.8, and then we had 6.0, is in the end a useless information if for realization it's months of effort to go there. But as we had this up front, it was a git pull and they were there. So with the first update from .NET 4.8 to .NET 6.0, the custom solution changed a lot in this release repository, but they got all the changes in. The worst part, they were making changes in the same area, and they would have to do a manual merge resolution or a manual merge conflict resolution. The actual .NET Core migration. Yeah, I think in the past we may have been a little bit sidestepped on some of those topics. I'm a little bit behind schedule. I'm sorry on this one. If I need to hurry up, just give me a shot. So from timing point of view, we're now going to take a look at this 2022 till late 24 time slot. And here, the number again, by late 2025, we had an order intake of 1.5 billion. So within 10 years, we pretty much tripled our order intake. And this becomes relevant later on. But take a look at the actual .NET Core migration. So there's stuff you know, there's stuff you know you don't know, and there's stuff you don't know you don't know. So we tried our best to prepare as good as possible. So what needs to be done in more or less detail to have an idea of what we're getting ourselves into. In the end, though, as harsh as it sounds, we had to get there. If it's a month effort or a year effort, it doesn't matter. We can't stay on .NET 4.8 forever. The pain only gets worse because over time you need to do a shitload of workarounds because the functionalities are not being provided for .NET 4.8 anymore. So you need to make your own custom implementation instead of relying on base libraries that are out for .NET 6 or something like this already. In our case, it was .NET 6 back then. Now it's .NET 10, but it has to be. We did have hard limits though. We need to keep shipping to projects. The order intake massively increased, so we couldn't say, screw you projects, you're not getting anything from us. I know you've sold a project that is worth 200 million euros, but we can't deliver anything to you because we need to bring .NET Core. This is something that wouldn't have been working. So we needed to be able to ship something to products and still have functional development in there. That was an unnegotiable hard limit. There were some soft limits though, as little break-in changes as possible. And if we have break-in changes, can we mitigate them by rolling out the updates? We didn't need to deal with binary compatibility anymore because the customer projects, since our delivery change, were the ones that were compiling everything. They had everything at hand. So every new deployment actually meant you have to run your compilation throughout the stack. We could remove shitload of our code in there because we didn't need to deal with assembly, redirect, handling, app domain loading, and all of this stuff. The customer is in control. It's not us anymore. We are pretty much just a framework by now. We're not an application anymore, we're a framework. Kind of a soft limit as well. Try to avoid a new major version as long as possible and as much as possible. Here as well, yeah, some minor changes can be done, some break-in changes can be done as long as they are reasonable. It shouldn't be, yeah, YOLO. I'm pretty much gonna break whatever I see fit. But if there are reasonable changes that can be argued, that have reasonable impact for the realization departments, then it can be fine. Major changes are something that are not easy for us. because we have a warehouse out there, and the warehouse has a life cycle of around 10 to 15 years, which means our software usually needs supported for 10 to 15 years. And if we bring in 23 a new major version, and in 25 a new major version, that means some kind in the order of 2035 to 2038, I can finally go there and say, delete this branch. Until then, I'm going to have to stand up for it, which also means I have to merge bug fixes throughout the major branches and so on. Stuff you know, dependencies. So which full framework or Windows libraries are we using? And I'm going to speed it a little bit up. From a high-level point of view, we had Unity 4, the DI container. We have the WCF communication, ODP managed, the managed Oracle data provider for .NET. And we had IIS and Kestrel. Part of the applications had Kestrel for some internal diagnostics in there for OTel endpoints and so on. But we still did run IIS separate as well, because 10 years ago or something like this, there was a bug in the OData link query that resulted in memory access errors. So we outsourced this into IIS and the gRPC communication along the way. And you can see this slide is in different format, different logo in here. This is still one of the actual slides back then from the first team meetings on the planning. So we have the Windows UI with .NET 4.8. Yeah, screw this, the Windows UI should go at some point in time already. We need to bring up a web UI. So we said, okay, the Windows UI is going to stay as is. We're not going to bring .NET Core on Windows clients in there. That's not reasonable. We leave this one out. The system, this core library, is something that we were rather soon. Okay, this has to be Net Standard 2. Because if it is Net Standard 2, it can be referenced from .NET 4.8, and it can be referenced in .NET 6 as well. And if we have this on Net Standard 2, Unity 4 brought out an upgrade after it was sunset by Microsoft, driven in the hands of a dying community, say it this way. Unity 5 brought up a Net Standard 2 as well, so we said, okay, yeah, this can be brought to Net Standard 2 as well. For WCF communication, yeah, maybe it's time to die right now. Maybe we can bring REST APIs, or at least HTTP APIs along the way. Oracle made our lives a little bit harder. ODP has a managed NuGet package that targets .NET 4.8, and because we're smart, we're bringing in an odp.manage.core for .NET 6 specific. But this also means, okay, in .NET 4.8 I have to target this package, in .NET 6 I have to target a different ones. Okay, now we're into dual compilation. So we can't make one single compilation. We have to do, okay, we're targeting. In our pipelines, we can bring in a build target, and if this build target is set, then we can run 4.8 or 6.0. If it's not set, then we say, okay, this is running in the IDE and based on IDE settings. And you can have conditional package references in there. And for Kestrel, there's the Kestrel is available as net standard, and our Windows UI.web can then be finally net standard as well. Spoiler, it's not. So pretty much we had the dependencies, we had our rough guideline, net standard 2.0 as much as possible. Dual compilation will be required at some point in time, as little as possible. Conditional compilation only if everything else fails, but yeah. I was talking earlier, we don't want to deal with your internal stuff, hide everything within your dependency tree, which meant we had a huge dependency tree that we need to figure out. And we already knew There was a lot of stuff and lots of dependencies and references that need to be refactored. But there were some nice ones as well and nice surprises. We did know up front the path separators on Windows and Linux will be different. We have a case-sensitive file system compared to an different one. From migration point of view, this was actually one of the nice. Our actual production code was in general nice. There were a few bugs in there where we had different casing and file names. There were more stuff in test cases where, okay, instead of path combine, just writing the path in there and using this one. Stuff you know you don't know. What we didn't know up front when we run on Windows versus on a containerized Linux. What about all the internals? What about debugging, performance analytics, garbage collection, thread pool handling, I/O operation, application shutdown in Kubernetes and so on? And this was, in general, a positive surprise. Garbage collection, I am that old. I remember changes from garbage collection from 3.5 to 4 to 4.5 to 4.6. It bit us every single time with server and client garbage collection modes and so on. Change to .NET Core was in that area a breeze. It worked fine, it worked smooth, there weren't any troubles in there. Garbage collection was fine, thread pool was fine, async I/O, application shutdown pretty much ran through. The expected performance issues almost didn't happen, beside logs. Log statements in C# are fast on Windows, they are fast on Linux. The Linux performance breaks down massively if you have heavy log contention. On this one, the performance plummets far, far away. The good part is our application code wasn't affected. The bad part, our application code wasn't affected. The hottest path was Log4j. Because we are that old. Just from an order of magnitude, a system under load from the MFC application is writing 1500 log messages per second from around 200 threads. So we were pushing Log4j to its limits in the past. We pretty much scraped each and every default depender, each and every default formatter. We just had this thin Log4j. In German, you would say Maschall, Feigenblatt, something like this. There was just a little bit Log4j left, and it bit us. We didn't need to do any fancy performance diagnostics. Application under load is crap. Dump. Okay, if I have 100 threads locking around the same resource, yeah, Log4j. That pretty much was it. So at least for the containerized version, we pretty much finally said goodbye to Log4j. It's not conditional compilation, it's just conditional branching in there. So during application startup, we check, are we running in a container? Yes, okay, screw Log4j, then we're just writing our logs to the console. This works fine, even in our 1500 messages area. Linux and Kubernetes is fast enough on this one. 1500 messages per second, however, are not the same application output. So this is something that needs to be addressed. It is on the backlogs for years, but you've seen the order numbers. So we've tripled the order numbers. And if I go in there and say, hey, I need to take one of my best developers on who knows on actually which application logs are reasonable and useful, and he can't work on the project-specific features for 2 months, the manager goes back, no. And yeah. Similar to the, I'm sorry I didn't update the caption up here. So this is not about locking, this is about string comparison. String comparison in .NET 4.8 and .NET Core and .NET Core on Linux behaves different. So if you do a equals operation, index of something like this, from functional point of view, there are subtle differences in there. I had to look up on this one. Windows has the NLS settings, Linux and Net Core are more into the ICU setting, and the ICUs are more correct, they are more compliant, they are more consistent, they are Unicode aware, more complex and much slower. So if you have this in hot paths, you need to take a look at this one. In our case, it was really easy because in the end, we're running in the server. In the back end, we don't have a culture there regardless, or anything that we can rely on or need to rely on. In our case, the fix was pretty much string comparison ordinal or ordinal ignore case throughout the stack, a couple of hours, and this was done. So the stuff you don't know, what was in the end pretty fine. Stuff you don't know. And the nice on this one, datetime precision and datetime resolution is much better in NetCore. So in the past, for logging, important for logging, not for measuring performance. If you want to measure something, still use stopwatch and don't calc the difference between date times. For logging, we were falling back to kernel 32 native APIs in the past, so we had the sub-millisecond timings in our log statements, because if you have 1500 log statements, you need to know what exactly was going on in there. And in the past, we were running through kernel API. This is something on NetCore, you can just use datetime now. It has high resolution in there. There is no semantic difference in there. Here as well, we should have catched it up front. Environment new line is different. In the end, it was one single mistake from environment new line, which on Windows is \r\n. In Linux, it's just \r, I think. Just because it's a one line of code doesn't mean that it is a 1 minute change. In the end, it was actual hours because it was shipped out to customer. It was running on site. It was running against a specific PLC where we needed to have this separator in there. So one realization engineer had to look at it, who was maybe in contact with the PLC engineers, which had to raise a ticket, which had to be brought back. So in the end, this crappy little bug was days of effort throughout the company. Should have caught it up front, we didn't. And you may remember this dependency graph from earlier. So we had the systems unity up here and the Windows UI.web down there. And suddenly, while they were initially in the stuff you know, they were in the stuff you don't know. ASPNET Core Net Standard. So I was checking on Microsoft ASP.NET Core MVC and MVC abstractions. It lists on frameworks and dependencies Net Standard 2.0, which is correct. So you can use it on .NET 6. You can reference it. You can compile it. You can start it up. And maybe 70–80% will work. But it's not supposed to work. It's pretty much intended directly for if we want to use ASP.NET Core on legacy application or on the .NET 4.8 framework, you can go up to ASP.NET Core version 2. But if you're on the full framework, you shouldn't reference the individual packages. You should use framework references. So suddenly, on this one, we're back to dual compilation again. So if I'm targeting .NET 6, I'm using the Microsoft ASP.NET Core app framework references. If I'm targeting 4.8, all the individual application logs, package references. If you can't read it, I can double tap Shift. Should I? Or the slides can be made available afterwards. Yeah. But it's not that easy. It's not just dual compilation. on the package level. Because in the end, you're targeting different ASP.NET Core versions. On the one hand, you're targeting ASP.NET Core 2. On the other hand, you're targeting ASP.NET Core 6, which means you have different APIs, which surprisingly is exactly reasoned by this missing method implementation error that I was running into when diagnosing this one. So from a single code base, I essentially had to reference two ASP.NET Core implementations. And I'm really the backend guy. I'm not deep into ASP.NET Core, and I had to figure this one out. So in the end, we had an ASP.NET Core abstraction layer in there with conditional compilation in there, where you could just say edge routing, you could provide your route, you could provide your pretty much minimal API function, and if you were targeting .NET 4.8, those underlying shims were called, and if you were targeting .NET 6, those underlying APIs were called. So this was kind of an abstraction in there. I spent too much time trying to make it work without the conditional compilation. I didn't want to have it in. In my opinion, it's not nice. I spent too much time. I could have saved days just saying, yeah, it's not going to work. Conditional compilation it is. And then we're back to Unity. So it was known that it had to be refactored, that we get our dependencies straight, and had to clean this one up. We needed some kind of inversion of control. Declare an interface and inject a reference to it. So from our base libraries, we can just say target net standard true, and I don't care if it's a Prometheus ASP.NET Core 6 implementation that's going to be injected. I'm just targeting the interface. Unity 4 was that they brought out Unity 5, and it was, what do we do? Refactor to something that we know is pretty much end of life. It's unsure if it's up for the task, if it can take the next 5 years, 10 years, or bring in a new IOC container. So we had to do a deeper evaluation on this one. And do you know this? And do you know the service provider service collection pattern in ASP.NET Core? Unity doesn't have, it does provide some kind of life cycle if you do it right and if you do it proper. But Unity allows you to go there, resolve something, register the same instance, resolve again, and you get different instances. The life cycle in between is gone. And if something is not enforced on an API level via exceptions, it's going to be misused or used to catch specific edge cases. It doesn't have to be bad intentions. If you're facing a problem, this works from an API point of view, yeah, I'm going to do that. Pretty much is as easy as that. But Unity was wild, wild west on this one. Microsoft, however, or Microsoft IOC container, that's the strict law and order. You had the service collection, you can bring the references in there, you can register types and so on. And at some point in time, from the service collection, you instantiate the service provider. And once you have the service provider, it doesn't care anymore what happens to the underlying service collection. The underlying service collection was used when it was instantiated. Then a copy was taken of the services and of the instances. If 5 minutes later, or 5 seconds, or a fraction of a second later, a new object was registered as well, don't care anymore. And I wouldn't call this a deal breaker for us, but it was, yeah, refactoring our application to go away from Unity into the service provider, service collection. That's a huge breaking change. This is so huge that we can't even hide this anyway. This is going to be visible to everyone because the complete application startup from add-in registrations, and although we don't dynamically load add-ins anymore, they are being injected from the outside, but the loading behavior, the structural workflow is still the same. So we at startup time, some parts of the application don't know what will happen 5 seconds later, what's going to be available and what's going to be injected in there. So making the hard switch from Unity to service provider, that's So we had to redecide again. Refactor to the dead horse, or bring in an additional IOC container. So for the applications, we're going to leave the Unity for the application build-up underneath, but from infrastructure point of view, the logging, the configuration, the references, and so on, we use the service collection service provider pattern. And it was a gut feeling decision. You know it should be done from a long-term perspective. You know it's going to be huge, immensely painful, and better not start thinking about how painful it's going to be, just start off. And we pretty much went all in on this IOC pattern. All of the stuff that we had in static convenience methods like logger manager, get logger, configuration support, get configuration settings, something like this. All of the functionality that we had in there was brought up as extension method to the service provider. And we just brought in a small shim, which we called runtime services, which couldn't be set by the applications. Applications were forced to, during startup, runtime services.initialize, then they got a service collection, then they could do whatever they want with the service collection. We provided 50, 100, 200 extension methods, add configuration, add logging, add managers, add ASPNET core, add OpenTelemetry, add Oracle databases, add tracking, recovery, and shitload of extension methods in there. So it's going to be easy to use. And the last statement that we forced applications again was if I run application loader that they could inject earlier, or use this one. And this was the end of the startup for us. From this point of time on, they couldn't inject any other types again. And from this part on, this runtime services class was sealed. So you couldn't make any changes on this one again. It was awesome for the general architecture of the code. So what we could do in there, what we could do from a cleanup point of view, from a testing perspective, everything improved a lot. And we finally fulfilled the initial promise that we gave out to the realization department. You are in control, you have the complete source code, you have the complete structure, the build infrastructure, and so on. But with this IOC change, the picture was full. The picture was brought together. Now they had complete control over the application as well. Devastating when taking into account the effort that was in there. The single IOC change. So this can be read from the background. This pull request was the, say, 85–90% change of all the net core code, of the actual net core migration. 2,400 files. 1,200 of it was test code, was test classes. And much of it was because of this IOC change. There was one specific type, I know exactly which one it was. If I just said, screw this one, this can be instantiated within, I would have spared 50% of the test cases and weeks of effort. I'm really talking about weeks of effort. Why am I talking about weeks of effort? Because this picture is slightly wrong. So it's not just stuff you know, stuff you don't know, the stuff you don't know, you don't know. Introducing stuff you did know could happen, but you thought it wouldn't. Number one, office politics. And I'm not talking about office politics in the dev team, not talking about office politics on a technical level. This was more on the bigger project. This .NET Core migration wasn't a project on its own. It was pretty much a sub-step of a bigger project, containerize everything, and one part of it was .NET Core. And this upside, do we really need containerization? Really, Windows is working fine, but we already have containers out. Yeah, Podman works as well for the specific ones, and for a short period of time we had a stack where we had containerized services like RabbitMQ or Redis. We had applications that were running natively on Linux, and we had applications that were running on Windows. For each individual component team, for the 100 developers, for them it wasn't a problem. For the 400 out in the field, for them it was a problem. Not counting in those 400 are pretty much the project managers that had to explain to customers on why our application suite needed 3 different operating systems. And all the documentation that had to be written for them, and for them. This was insane, but we had the office politics in this one. And number 2, we were successful in the markets, which in itself is fine again because you're getting revenue, you're getting money in, but it was to the point that part of the resources from the development teams, or many of the development teams, couldn't work on the actual migration anymore. So we had, on the one hand, we had lots of office politics, and office politics are pretty much a delay. So each and every discussion delays and delays and delays and delays. You have to spend time, effort, and energy going into those discussions, setting up, preparing meetings, preparing slides, going 15 extra rounds with stakeholders and so on. All of this takes time. And while you pretty much spend up in this time, the development team moves on because we have to ship features, which is completely understandable for their from their point of view. And in the end, this resulted in a huge merge hell. So now we had one developer that I was pretty much the sole developer left for half a year or a year, something like this, working on this migration. But I had to do the general containerization, stakeholder meetings, Kubernetes evaluation, and so on as well. And in the meantime, 20 developers were cranking out features pretty much as quick as they can, but on a different code base, because I was still in the migration. So every 2 weeks, yeah, okay, I'm gonna grab in the latest changes. 200 files change and merging them through. So you're gonna spend 2 days again merging. And 2 days were spent merging. But now we are pretty much through. Maybe just a wrap up. So from a timeline point of view, in 2021 or late 2021, the decision was made, go into this containerize everything. The staffing and the planning for it started. .NET Core wasn't a project on its own, it was part of this bigger containerization. In around 2022, we had this Kubernetes platform evaluation, and the first prerequisites on the actual .NET code already came in 2022. And pretty much all of 2023 was Kubernetes focused and politics focused, a re-evaluation of the platforms, and so on and so on and so on. And finally, around 2024, in the first half of 2024, we finished the heavy lifting of the .NET Core migration. In the second half, performance tests, load tests, and in the second half as well, the first installation at customer sites. And in 2025, we pretty much rolled it out worldwide, as long as with trainings, and it's now it's the default installation method for each and every customer. Maybe some kind of lessons learned, quick lessons learned. The preparation, the actual required stuff was okay. You can always spend more time planning, but at some point in time, the actual yield of planning time doesn't improve anymore. In general, on the server, on the backend, on the stuff that we thought problems would come up, most of this went rather smooth. So the actual, if you run on Windows or on Linux, the runtime differences, all of this was okay. The code migration and so on, this was pretty much fine. Migration effort at least doubled with this single IOC change, at least doubled. In hindsight, shortcuts could have been taken. I could have been less stubborn and say, okay, this is good enough this way. In hindsight, you're always smarter. And vastly underestimated the impact on test projects. This is something that I didn't have on my radar. There's thousands of test classes and shitload of inheritance in there. Yeah. What brought it down? This single IOC change, so we could go to net standard. This should have been brought in smaller chunks, so we could bring smaller chunks to the code base, and this merge shell wouldn't have happened. Longer term benefit is definitely there, but the migration was crunchy, very crunchy. Soon after the completion, I announced it earlier, we pretty much forked it out again, and those base libraries were moved out into the dedicated repo, into the dedicated project. And from there, we could make it available to all the .NET teams in a clean way. We didn't say, okay, we have to do this because we started our code base 20 years ago. At some point in time, we could make some application changes from the structure, from the bootstrapping, and so on as well. And you can actually take a look at sonar scanning results again. And this is pretty much now the current state. So you pretty much start off with runtime services initialize. You can say this is my application name. You add the runtime defaults, the OTel endpoints, the implicit I want to provide. I want to connect to an iSample service that is available on this location. I want to provide a specific instance of a service in there. And if you want to start up a new component in our stack, you now have to implement a service class, and you have to describe an interface, and you get pretty much Kubernetes integration, the messaging integration, authentication, the health endpoints, all of this for free, by writing one interface and one implementation for it. So on this one, we're at least in the interim. Maybe in 10 years or 20 years, we're going to see each other here again. And I can give you a migration report. Yo. That's it from my side. Any questions from you guys? Are you still awake? Yeah, sure.
How do you evolve the platform? Is also from the realization teams, is the feedback coming back into the platform that you then integrate, or is this kind of a one-way communication thing?
The question was about how the platform is involved. Am I doing it right? How the platform involved, if this is a bidirectional one, or if we're pushing something to them. In the meantime, and this is something, especially in this project, we've established really good counterparts within the realization units. We can discuss stuff with them. We say, hey, we want to head in this, and this direction. And what's your feedback on this one? On the, general high-level topics, there's always consent up front. There's not always consent on each and every detail in there. This definitely not, but on the rough direction there is consent. for better or for worse, because the projects and because the units are selling that much, they're coming with much more confidence in there, which is a good thing. In the past, it was, we're PD, we know what you guys need. That's the way to go. And it doesn't work. Because we from PD, we don't suffer the same problems that they have. We are the technical experts on specific islands, on say specific areas. And usually the best PD developer is better in .NET than the best realization. But he's not the better developer, because the realization guy has also know the Java stack, he has to integrate everything, and he has to know all the warehouse processes and so on. In each component, you have one developer that is definitely better than one in the realization on this specific component. And with this project as well, as embarrassing as it is, this was pretty much the kickoff, or this was the triggering point that all the components have to work the same way. And this is something that we're forcing them right now. So this general, say, platform architecture, we have some rough requirements from security point of view and so on. Some stuff is not negotiable. I can decide it as well. This stuff needs to happen. But the general direction and the general stuff is agreed on with the stakeholders. We have in those different realization units, because we have the 6 major realization units. They are grouped into geographic regions. They have the stakeholders, they have their internal communities, which is really important. And if push comes, they have one spokesperson. I don't need to talk to 15 realization engineers anymore. This is the one that I have to persuade, and that can also say, yeah, this is not going to happen. And he says it. And he says, we're getting from customers those, and those requests. What can you bring to us to make this better? This is something that's definitely improved a lot in the last 3 to 5 years.
So do they also contribute directly back to the source?
They can. But on this one, this is now the vice versa topic. Realization guys work different. They have to work different. In product development, you don't know the exact implementation. Realization ones, they focus on this problem. That's pretty much the stuff that I have to solve. They have a different mindset. It's not a better mindset. It's not the worse mindset. It's a different mindset. And experience in the past by this cross collaboration between PD and realization was mixed. If you get a really good realization guy, he can work in PD. But the really good realization guys, they usually don't let them out. It can work. Code is pretty much open. So all of our hundreds of repositories internally are in general read-only to everyone, but they have read access. We are shipping the PDBs with source indexing and so on. All of this is in there. And they can contribute to the code, and vice versa. It can also happen, I have a problem in this code and I get the Azure DevOps link in this file. This happens. What am I doing wrong? So we have good collaboration, usually. Yeah.
All right. As you're a little bit over time already, I think we're going to move all the other questions to the pizza and the beer. Klaus, thank you very much for coming. Thank you for the presentation. As usual, little speaker present. Please, big round of applause.